Hello everyone, welcome to LimeGuru channel. In this video, we will learn about quantum computing. So we'll start with the current landscape, that how computing happens in today's scenario in case of classical computers or the supercomputer, how computing happens today. And then we'll discuss about the quantum computing, what it is, how is it different from the existing compute that we have running on supercomputers or the classical computers. Then we will discuss about certain core concepts of quantum computing, which is qubits, superposition, entanglement. And in the last, we will discuss about that where we are in the landscape of quantum computing and what are some of the potential use cases which would be the target for the quantum computing in first go. So we'll talk about all of those things, and some of these things might be new to you, so don't worry, this concept is completely new, so you will be getting a good understanding of quantum computing, the basic understanding. You'll get to know like how quantum computing is different from today's compute and what benefit it brings for the future. So let's get started. So the first thing we are going to discuss, I just want to explain you in brief that how the computers behave today, the computers that we have today in our home, in our organization, in our data center. So wherever computers are there, it could be a classical computer or it could be a supercomputer, whatever case it is. So we'll talk about that what is the current landscape. So let me write down here the current landscape. So there can be two type of computers today. So one could be the normal computers, which is the classical computers. So the classical computers could be the servers where your application is running, or it could be the computers in your home, it could be PC, laptop, whatever it is. So all those are classical computers, which can have memory. Let's say in terms of, you can have a classical computer of 16 GB of memory, or it can have 32 GB of memory, or it can go up to, let's say, 128 GB of memory. So all of these computers can fit into a category of classical computers. And supercomputers are certain powerful computers which can have memory of up to, let's say, 300 to 400 GB of memory. So these are so big computers, and they can process your information faster compared to the classical computer because of the processing power they have. So they can definitely run the heavy compute. But how it runs the compute? So let's understand the underlying architecture. So every information within your computer is represented in the form of a bits. So it's represented in the form of either 0 or 1. So this is the fundamental thing that you need to understand, that your computer understand either a 0 or a 1 or a combination of 0 or 1, right? So let's say if you have 0, computer will understand it differently. If you have 1, computer will understand it differently. If you have combination, let's say 0 1, then this is a different information. If you have 0 1 0, it is a different information. If you have 0 0 1 0, so any combination of 0 or 1, or 0 or 1 in independent. So this is the information which your computer interprets and takes the action depending on what bits you are sending to your computer for processing. So this is how your classical or supercomputer behaves. It operates on this fundamental principle of bits. But what is the problem here with classical and supercomputer is that irrespective whatever memory you can have within your computers, let's say if you take an example of supercomputer of 400 GB, you can only process finite amount of 0 and 1. So it could be, you can increase this information, you can increase the number of bits in terms of 0 and 1, but it is still finite amount of information. At some point of time you will feel that that this 400 GB is also less. The type of use cases that we are working on in today's world, the internet is moving so fast, it is getting advanced so fast, and the type of compute we need, even the supercomputers are also not able to solve those complex problems. So irrespective whatever computer you have, it's always represented in 0 1 0 1, and at some point of time, let's say when you have a very large amount of information to be processed in the form of 0 1, so this processing power is again going to be slow in future. And even in today's scenario also, there are a lot of complex problem which takes time even on supercomputers also, which could be in the healthcare domain, or it could be let's say very highly secured system where you need to have the high level of security and you need to implement security. and there are a lot of other use cases in the world of artificial intelligence and machine learning also. So even these high processing powers also are less, because the information is stored in a binary format, which can have values either a 0 or a 1. So this is the current landscape, and to solve this problem only, now the lot of research is going on in the world of quantum computing. So we'll now talk about quantum computing here. So what is quantum computing? So quantum computing, it's a new way of doing the computation where the information is not only stored in 0 and 1. It's not only stored in 0 and 1 form, but your information can take the state in between 0 and 1 also. Just to explain it in a better way, let's take an example. Let's say you have a coin, right? Now if you flip a coin, either you can get head or you can get tail, right? Now let's say head is 0 and tail is 1. Now your classical computer or a supercomputer can understand that this information only, that head is 0 and tail is 1. But what about those cases when your coin is flipping? Let's say when you're flipping your coin to get head or tail, when you are flipping your coin, so the coin is still flipping. Let's say it's flipping in the air or it's flipping on the table. So it has some state at that point of time also. It is not head or tail, but there is still some state which is different from head and tail, which is when your coin is moving. It's in a moving state. So there is some fluid state, right? So that fluid state our classical computer does not understand. And to solve this problem, this quantum computing came into picture, that in between 0 and 1 also we have many states. There are endless states in between 0 and 1, which quantum computers can understand. So quantum computers can understand the states in between 0 and 1 also. And this is similar to the principle of quantum mechanics. So this is similar to the principle of quantum mechanics in physics. If you relate it with the concept of atoms, or you relate it in the terms of molecules. So when molecules are moving or atoms are moving, so it's not in a moving position, they have different states, right? And those states can be endless, right? So it's not 0 and 1. It's not in a binary format. It's a fluid thing. It's always moving. The things are always moving in terms of quantum mechanics in the physics world. And that is how the quantum computing is also based on the same principle, that quantum computers will not work on the principle of bits. It will not work on the principle of bits. So bits can have 0 and 1 only, but quantum computers can have endless states. In 0 and 1 is definitely there, but in between 0 and 1 also there can be endless states which quantum computers can understand. So that is the fundamental difference between a classical or supercomputer which we work on today, which uses the concept of bits, and a new concept which is based on the quantum mechanics, which can have multiple states, 0 and 1, and endless states in between 0 and 1. And this concept is called qubits. This is called qubits in quantum computing. So the way we call bits in existing computers, in quantum computing it is called qubits. So every qubit can have multiple states. It's not limited to binary format. It can have multiple states, and those states could be fluid in itself. So that is so this state which this quantum computer maintains, this state terminology is called qubits. Now, as I said, that it works on the principle of quantum mechanics. So we'll discuss what are the basic properties on which it works on. So we'll discuss about certain quantum mechanics properties, and these quantum mechanic properties are primarily, which we are going to cover in this video, these are superposition and entanglement, and we are going to discuss both of these properties in detail now. So what are these two properties? So as I just said now that quantum computers works on the principle of qubits, right? Now qubits can have multiple states. Just take an example of 0 and 1 only, and it can have multiple states in between 0 and 1, infinite states in between 0 and 1. So this principle is called superposition, that you can have fluid states, you can have endless states. There is no limitation on the number of states you can have. You can have limitless permutation or combination of different states in between 0 and 1, and this concept is called superposition. And this is one of the property in quantum mechanics, that your state could be fluid, your state is not binary, your state is not static, it's a fluid state. And this is based on the quantum mechanic property superposition, and this qubits in exhibit this property of superposition. And the quantum computers are being designed, the research work that's going on, the first implementation for quantum computers which has been rolled out, so it uses superposition concept to maintain these endless states. Now superposition we have talked about. Now what is entanglement? So let's take the example of quantum physics again. Let's say you have one atom and you have another atom, and when you combine these two atoms together, then you get a new state, I'll say, right? So when you combine the atoms together, or I'll say when you entangle those two atoms together, you get a new state in quantum physics. So in a similar way in quantum computers also, let's say you have one qubit and you have another qubit. So when you combine these two qubits, when you entangle these two qubits, it becomes a new state. And this is also one of the way to get more number of states. So one way we discussed here that you can have endless states within one qubit, but here what we are talking about, that when you combine multiple qubits also, when you entangle multiple qubits also, you get new states. And when you have entangled these two qubit 1 and qubit 2, and let's say if you make any change in qubit 1, it impacts the qubit 2 also. Again, this is based on the quantum mechanics in physics, that if you change something, if you change any atom properties, it impacts other things also, right? So entanglement is the concept of getting more higher number of states by entangling two qubits, or by entangling two different states, and changing one state impact other states also. And that is the fundamental principle in quantum mechanics, and this is the concept of entanglement. So now we have discussed, now you would have got the fair idea that in classical computers what we used to have was only 0 and 1. Now you don't have 0 and 1, you have 0 and 1, and you have infinite number of states in between 0 and 1. And also, let's say if you have multiple qubits, let's say this is my qubit 1, this is my qubit 2, where we have 0 and 1, you can have an unlimited number of states in between 0 and 1 for qubit 2 also. And if you combine these two also, you get a new state. So this is just an example. You can entangle multiple qubits, not just limited to 2 qubits. You can entangle multiple qubits to reach to your desired state. And this is how the new type of computing is being implemented in quantum computers, that you don't have any limitation on the states. You don't have limitation that your state is going to be 0 and 1. These computers can store much more information as compared to these computers where we used to have representation 0 and 1. We cannot have more number of combinations because of this binary presentation, but here we can have many combination, endless states. Here we can have, and every state in a computer, it's an information, right? So you can store much more information, you can process much more information, you can do very heavy compute, which is not possible even in today's supercomputers also, because of this basic this basic thing, this basic architecture being laid down from the ground level itself. So I'll not say that these computers are transformed, these classical computers are transformed in a quantum computers. It's not like that. It's not like that. It's not a transformation. It's completely a different architecture from the ground level itself. So these computers are designed differently, and these computers are designed completely differently from the ground level, from the lowest level of architecture, that how computer processes the information. So these designs are completely different. So I'll say these machines are completely different in itself. It's not computer. It's a completely different kind of machines. The only similarity you will find is that these machines are also used to process the information and to get the output, and these machines will also be used to process the information and to get the outputs. That is the only similarity, but the machines are totally different. So the underlying architecture is completely different. So just to repeat, it works on the bits principle, and it works on, and quantum computer works on the quantum mechanic properties. And we discussed two properties here, which is superposition and entanglement. And there are a lot of other quantum mechanic properties also which are being laid down as part of quantum computers. Let's say interference, coherence. So multiple quantum mechanics properties are being laid down in this competition, and we are not going to discuss everything here in this session, but the idea is just to give you the understanding how quantum computer works and how it is different from our classical computers. Now I'll talk about where we are in this space, in this research. So many big companies, let's say Google, IBM are investing a lot in this domain to create these quantum computers. And one of the quantum computer has already been created by IBM, which is available on cloud, and anyone can access it onto the cloud to do the computation. Now these systems, these quantum computers requires a temperature to be colder than our room temperature. So they cannot operate at room temperature, and it's because of the underlying principles. It's based on the quantum physics. So that's why it cannot work on to the room temperature. It needs a colder temperature, and that's why it's being kept in a special infrastructure in IBM centers, and you can access it via the cloud to do the computation. But the point I want to raise is that quantum computers are already being built. They have already been in place, and you can access it onto the cloud, and a lot of work is going on that how it can be made available to the users more easily, right? So that those research work is already going on, and the future is about quantum computers only, and a lot of things are going to be driven from quantum computers because of the endless possibilities now we have with the compute that it offers. So now we'll discuss about some of the use cases that where quantum computers would be helpful. So we'll discuss about certain use cases here. So if I talk about the use cases, so quantum computers makes a perfect sense where you need a very heavy compute and you want the results fast, right? So you want fast results, but your compute is very heavy. So in those cases, quantum computing will help, or you will need quantum computing where you are running out of space in supercomputers or your classical computers. So we will discuss about some of the cases. For example, let's say security. So whenever you want to secure the data, you encrypt it with some private key, right? Now in classical computers, irrespective how complex your security algorithm is, hackers are able to get those private keys. So they are able to hack your private keys, and it is again because of the limitation that even the supercomputer can have limited information, and hacker can interpret, can get that private key because of the limited information we can process or we can get from a supercomputer. So it's in the security world also, this quantum computer are going to help, because we will not have limited number of private keys. We'll have endless private keys now with the quantum computing. And the state, because it's based on the superposition property, the state is going to be fluid. It's not going to be fixed state. So it's going to be a fluid state, and hackers will not be able to identify that fluid state because of the way this quantum physics works, because of the way that qubits works. So it's going to be highly beneficial in those cases where you want to secure your data, or you want to have a heavy security onto your machine. So in those cases, this quantum computing is going to help a lot. Second use case I'm going to talk about is healthcare. Now, healthcare is something which is connected, that how drug discovery happens, which is based on the principle of molecules only, right? And how certain diseases are treated. For all of these cases, which takes time, because it's based on the molecules, and molecule has to be represented today in a classical system in binary format, which is not the right way of which is not the similar way that how drug operated. So that's why these systems are getting designed, that we can have a molecular representation only at the computer level, at the hardware level, and it can be based on the same principle, the way how drugs works, right? How the medicine works. So it's going to be very helpful to have the similar system, the way the medicines works. Actually, it can be represented, that the same information can be represented in the same similar way in quantum computers. So this it's going to speed up the process of drug discovery and curing the diseases. So it's going to help a lot in all of these cases. And the third case I will talk about is the financial cases, where let's say the financial data is changing at a very rapid pace, right? And let's say you want to create some portfolio where you want to invest certain money, but because financial data is changing so fast, so you can leverage these quantum computers which can process this financial data very fast, and it can help you to create a better portfolio compared to how the portfolios are created today. So, and it will help you to gain much better than today's predictions. And the last use case I want to talk about is in the world of AI and machine learning. And we all know that this is one of the trending thing which is being taken in every organization today, that most of the organizations are trying to implement machine learning and artificial intelligence, and the algorithms have become so complex today that even today's processing power, even the compute that we have today, even that is less for AI and machine learning use cases. So in all those cases also, this quantum computers can help us a lot. So these are all about the future use cases, and as I said, it's going to be a very promising technology once it is rolled out to a broader audience, and once more research work is completed. So it's going to be a huge success. It's going to be the I'll say it's going to be a new trend. The way we operate computers, it's going to be a new trend in the future in the domain of computing. So that's what I wanted to cover about quantum computing. Just to give you a recap, we talked about the current landscape, where we discussed about classical computers and the supercomputers, and then we talked about quantum computing, that this is based on the principle of qubits, and qubit works on the principle of quantum mechanics properties, which is related to superposition and entanglement. Superposition is basically having a fluid state, not a binary state, and entanglement is that getting more and more states by entangling two or more qubits together. And then we talked about who all are investing today and where we are today in terms of quantum computing, and then in the last we talked about certain use cases, that how it's going to benefit the future. That's it about this video. I hope you got the basic concept. If you like this video, please press the like button, do share this video with others, and do support us by subscribing our channel. Thank you.